Okay, in the last video, we left off talking about what a parent chain is, and I have the definition up here again. The parent chain is the longest continuous chain of carbon atoms, and we were making a set of rules, and the first thing that we wanted to do is to find the parent chain. So now we're going to build upon those rules and look at another example that's a bit more challenging. And let me draw this for you. So the thing that I notice first that looks different about this molecule is we do have that kind of straight chain that goes across, but we have this kind of extra thing coming off. Now this extra thing ends up being called a substituent, and let's define that. A substituent is single atoms, or a single atom, depends, attached to a parent chain. Hydrogen doesn't count. And you can kind of think of a substituent as a branch. So if I wanted to identify the parent chain of this molecule, it's not as simple as the other one. The other one, we just were able to go straight across and know that that's the only way to really number this as a parent chain. But this one is different. We could actually start here and go down that way. We could start here and go up that way. There's a lot of different ways that you can kind of number this parent chain. Actually, 3 ways to be precise. And the first thing I want you to do when you're trying to name a parent chain that has kind of multiple substituents or a single branch on it is, we'll add to our list of rules here, consider terminal carbons. That's what I was drawing before. So what do I mean by terminal carbons? Well, this is a terminal carbon here, this is a terminal carbon here, and this is a terminal carbon as well. They're basically carbons that are at the end of the chain. These are all potential starting points and ending points for the parent chain. So by looking at these 3 terminal carbons, or however many terminal carbons are in the molecule you're looking at, you can see these places where you could potentially start and you could potentially end your parent chain. So let's say that we numbered the parent chain going directly across. What would end up happening is I would have 1 carbon here, 2 here, 3, 4, 5, 6. So going straight across gives us 6 carbons. But is there a way that we could have a longer continuous carbon chain? What if we went down here? Well, what would happen is we would actually get 1, 2, 3, 4, 5, 6, 7 carbons if we number the parent chain going down this way versus straight across. Now what ends up happening is that that's the correct parent chain because it's the longest continuous chain. Going across here will just give you 6, but going straight down this way will give you 7, and that's the definition of the parent chain. You want to have the longest continuous carbon chain. So that is how we would name this parent chain, and let me redraw this down here so it doesn't get too messy. So we've now numbered the parent chain, and I'll highlight that parent chain for us in green here. And the next thing you want to do, and I'll write this over here, is identify and name any substituents. So a substituent, remember, is a single atom attached to a parent chain. So here we have our parent chain, but then we see this thing coming across or off the parent chain. Now what is that? Well, that is actually a substituent. And what is important to note here, and a lot of people get confused about this, is there is a carbon right here, there's a carbon right here. But the carbons can't be both part of the substituent and the parent chain. So let me write that down. So a lot of people get that confused. Now here, this carbon is part of this parent chain, so it's not part of the substituent. This is the only carbon part of the substituent. Now, if we were to name this substituent, it would end up being called a methyl group. But how do I know that? Well, there's another little list you have to memorize. A 1-carbon substituent is called a methyl. A 2-carbon substituent is called an ethyl. A 3-carbon substituent is called a propyl group. And a 4-carbon substituent is called a butyl group. So these are something that you have to memorize as well. So that's how I was able to name this substituent as a methyl group. Now, how would we name this molecule? We kind of have all the puzzle pieces. Well, the last rule that I'm going to add here for now is to number the parent chain. So the substituents get the lowest number. So what do I mean by that? Well, I could number this parent chain as follows. I could go start at the left, 1, 2, 3, 4, 5, 6, 7. That would put the substituent at position 5. But what if I number the other way, and I number this 1, 2, 3, 4, 5, 6, 7? What's the difference? Well, it's still a 7-carbon chain. I've numbered it the same. But now the substituent in this order is at position 3 versus left to right, it was at position 5. So this is what I mean by numbering it so the substituent has the lowest number. We would want to number it this way because the substituent would have a lower number. So how would we name this molecule now? Well, it's a 7-carbon chain, so that's heptane, and we have a methyl group at position 3. So we would name this as 3-methyl heptane. So let's break this down. The 3-methyl tells us that there's a methyl group at position 3. And this heptane tells us it's a 7-carbon chain. So how this nomenclature kind of works is you always want to identify the parent chain. That's what tells us the heptane. Then we would identify any substituent. So we identified the methyl substituent here. And then I numbered the chain so that the substituent got the lowest number. It would not be 5-methyl heptane. That would be a different molecule. So it's very important that you number it so the substituent has the lowest number. And this, in this case, going from right to left would give you a position of 3. So you always write the position number dash the substituent and the parent chain name, all one word. So the substituent and the parent are one word, there's no dash, but the position number of the substituent goes before the dash. So it's the position number of the substituent, a dash, and then the substituent and the parent name chain all at once. So this is how you would name a simple alkane with a parent, as a parent chain with a substituent.